Have you ever wondered how a YouTube like button remembers your clicks, or how a shopping cart keeps your items while you continue shopping? These features rely on one of JavaScript's most important concepts, functions and closures. Functions are everywhere in modern development. They're used to build React components, Next.js pages, Node.js APIs, button click handlers, and countless features in real applications. Today, you'll learn how functions work, how JavaScript executes them, and how closures allow applications to remember data. By the end, you'll build a feature that behaves like real production software. Let's set up our project. Create a folder named functions-closures-demo. Inside it, create 3 files: index.html, style.css, script.js. Open Chrome DevTools and keep the console visible so we can watch JavaScript execute in real time. A function is simply a reusable set of instructions. Think about a coffee machine. You don't rebuild it every time you want coffee. You simply press a button and it performs the same steps. Functions work exactly the same way. Let's build one. Notice nothing happened. We've only defined the function. To execute it, we must call it. Now JavaScript enters the function, runs every instruction, then continues reading the rest of the file. Let's visualize what JavaScript is doing. It reads the file from top to bottom. When it finds the function, it stores it in memory. When it reaches it, jumps into the function, executes the code, and then returns to continue reading the file. This process happens every time a function is called. Imagine building YouTube or an online store without functions. You'd have to copy the same code over and over. Functions solve this by organizing code into reusable building blocks that are easier to maintain and scale. This is why every modern JavaScript application relies heavily on functions. So far, our function always behaves the same way. Next, we'll make it flexible using parameters and return values. Instead of printing the same message every time, let's allow our function to greet different users. Now we can call it with different values. The same function now works for any name. What happens if we forget to pass a value? The output becomes hello undefined. The function didn't fail, it simply didn't receive any input. Understanding messages like this is an important debugging skill. Instead of guessing, inspect the input. Logging values like this quickly shows what your function receives. Printing values is useful, but real applications usually need functions to produce results. That's what return does. Now we can store and reuse the result. Return values allow functions to communicate with the rest of the program. Real applications use return values constantly. A login function returns whether authentication succeeded. A shopping cart function returns the total price. A weather function returns data from an API. Functions don't just perform actions, they produce data that other code can use. You'll commonly see 3 ways to create functions in JavaScript. Function declaration. This style is hoisted, meaning it can be called before it's defined. Function expression. Here the function is stored inside a variable. Unlike function declarations, it must be defined before it is used. Arrow function. Or even shorter, arrow functions are heavily used in React and modern JavaScript. Remember these key ideas. Parameters receive input. Arguments are the actual values passed to the function. Return sends output back. Function declarations, function expressions, and arrow functions all create functions. They mainly differ in syntax and behavior. Scope determines where variables exist and where they can be accessed. Let's begin with global scope. Because this variable is global, both inside and outside functions can access it. Global variables are powerful, but they can also create bugs. Since every part of your program can change them, they should be used carefully. Variables created inside a function stay inside that function. Trying to use the message produces message is not defined. JavaScript protects local variables from being accessed outside their scope. Let's build a simple counter. Each time the function runs, count is recreated. So how can JavaScript remember previous values? That's exactly what closures solve. A closure allows a function to remember variables even after the outer function has finished running. This creates private memory inside your application. Let's build a simple login attempt tracker. The outer function has finished, but attempt still exists because the inner function remembers it. That is a closure. Place a breakpoint inside the returned function. Step through the code. Notice that attempts isn't recreated each time. JavaScript keeps that variable alive because the inner function still uses it. Watching this happen in DevTools makes closures much easier to understand. Closures are used throughout modern applications. They power click counters, user sessions, shopping carts, analytics, timers, event handlers, and many React hooks. Closures let developers keep data private without exposing it globally. Today you learned that functions store reusable instructions. Parameters receive input, return values, produce output. JavaScript supports 3 function styles: function declaration, function expression, arrow function. Scope controls where variables exist. Closures allow functions to remember private data. These concepts are fundamental to React, Next.js, Node.js, and virtually every modern JavaScript application. If you enjoyed this lesson and learned something new, subscribe so you don't miss the next episode. In the next video, we'll explore one of JavaScript's most misunderstood concepts, the this keyword. Once you understand how this works, reading and writing JavaScript becomes much more predictable. I'll see you in the next lesson.